Chandrayaan-3 is the third Indian lunar exploration mission under the Indian Space Research Organisation's ISRO Chandrayaan program. It consists of a lander named Vikram and a rover named Pragyaan. Similar to those of the Chandrayaan-2 mission, the propulsion module carried the lander and rover configuration to lunar orbit in preparation for a powered descent by the lander. India's moon rover has taken first steps on the lunar surface a day after the country made history by becoming the first to land near the South Pole. Chandrayaan-3's rover ramped down from the lander and India took a walk on the moon, the space agency said. With this, India joins an elite club of countries to achieve a soft landing on the moon after the US, the former Soviet Union and China. The 26 kilograms rover called Pragyaan, the Sanskrit word for wisdom, was carried to the moon in the Vikram lander's belly. Chandrayaan-3 was launched on the 14th of July 2023. The lander and rover landed near the lunar South Pole region on the 23rd of August 2023, 1802 IST, making India the first country to successfully land a spacecraft near the lunar South Pole and the fourth country to soft land on the moon. On the 22nd of July 2019, ISRO launched Chandrayaan-2 aboard a launch vehicle Mark III LVM-3 launch vehicle, consisting of an orbiter, a lander and a rover. The lander was scheduled to touch down on the lunar surface in September 2019 to deploy the Pragyaan rover. The lander ultimately crashed when it deviated from its intended trajectory while attempting to land. Following Chandrayaan-2, Chandrayaan-3 and further lunar missions were proposed. The European Space Tracking Network (ESTRAC), operated by the European Space Agency (ESA), is supporting the mission under a new cross-support arrangement. ESA tracking support could be provided for upcoming ISRO missions, such as those of India's first human spaceflight program, Gaganyaan, and the Aditya L1 solar research mission. In return, future ESA missions will receive similar support from ISRO's own tracking stations. ISRO's mission objectives for the Chandrayaan-3 mission were getting a lander to land safely and softly on the surface of the moon, observing and demonstrating the rover's driving capabilities on the moon, and conducting and observing experiments on the materials available on the lunar surface. To better understand the composition of the moon, Chandrayaan-3 comprised three main components: propulsion module, lander and rover. The propulsion module carries the lander and rover configuration to a 100 kilometers, 62 miles lunar orbit. It is a box-like structure with a large solar panel mounted on one side and a cylindrical mounting structure for the lander, the intermodular adapter cone on top. The Vikram lander is responsible for the soft landing on the moon. It is also box-shaped, with 4 landing legs and 4 landing thrusters capable of producing 800 newtons of thrust each. It carries the rover and various scientific instruments to perform on-site analysis. The lander for a Chandrayaan-3 has 4 variable thrust engines with slew rate changing capabilities, unlike Chandrayaan-2's lander, which had 5, with the 5th one being centrally mounted and capable only of fixed thrust. One of the main reasons for Chandrayaan-2 landing failure, attitude increase during the camera coasting phase, was removed by allowing the lander to control attitude and thrust during all phases of descent. Attitude correction rate is increased from Chandrayaan-2's 10 degrees per second to 25 degrees per second with Chandrayaan-3. Additionally, the Chandrayaan-3 lander will be equipped with a laser Doppler velocimeter (LDV) to allow measuring attitude in 3 directions. The impact legs have been made stronger compared to Chandrayaan-2, and instrumentation redundancy has been improved. It will target a more precise 4 kilometers to 0.5 miles by 4 kilometers to 0.5 miles landing region based on images previously provided by the orbiter high-resolution camera. Onboard Chandrayaan-2's orbiter, ISRO improved the structural rigidity increased polling in instruments, increased data frequency and transmission, and added additional multiple contingency systems to improve lander survivability. In the event of failures during descent and landing, lander payloads include Chandra's surface thermophysical experiment CHASTE will measure the thermal conductivity and temperature of the lunar surface. Instrument for Lunar Seismic Activity SA will measure the seismicity around their landing site. Langmuir Probe LP will estimate the near-surface plasma density over time. The Pragyaan rover is a 6-wheeled vehicle with a mass of 26 kilograms 57 pounds. It is 917 millimeters, 3.009 feet, x 750 millimeters, to 0.460 feet x 397 millimeters, 1.302 feet in size. The rover is expected to take multiple measurements to support research into the composition of the lunar surface, the presence of water ice in the lunar soil, the history of lunar impacts, and the evolution of the Moon's atmosphere. The rover payload include Alpha Particle X-ray Spectrometer (APXS) will derive the chemical composition and infer the mineralogical composition of the lunar surface, and laser-induced breakdown spectroscope LIBS will determine the elemental composition of lunar soil and rocks around the lunar landing site. Chandrayaan-3 was launched aboard an LVM-3M4 rocket on the 14th of July 2023 at 2:35 p.m. IST from Satish Dhawan Space Center, second launch pad in Sriharikota, Andhra Pradesh, India, entering an Earth parking orbit with a perigee of 170 kilometers, 106 miles, and an apogee of 36,500 kilometers, 22,680 miles, after a series of maneuvers that placed Chandrayaan-3 in a translunar injection orbit. ISRO performed a lunar orbit insertion LOI on the 5th of August, successfully placing the Chandrayaan-3 spacecraft into orbit around the Moon. The lunar orbit insertion operation was carried out from the ISRO telemetry, tracking, and command network ISRO located in Bengaluru on the 23rd of August 2023. As the lander approached the low point of its orbit, its 4 engines fired as a braking maneuver at 30 kilometers, 19 miles above the Moon's surface. After 11.5 minutes, the lander was 7.2 kilometers, 4.5 miles above the surface. It maintained its altitude for about 10 seconds, then stabilized itself using 8 smaller thrusters, and rotated from a horizontal to a vertical position while continuing its descent. It then used 2 of its 4 engines to slow its descent to roughly 150 meters for 190 feet. It hovered there for about 30 seconds before continuing downward and touching down at 12:32 UTC. The landing coincides with the start of a lunar day. A day on the Moon equals 28 days on Earth, and this will mean the lander and rover will have 14 days of sunlight to charge their batteries. Once night falls, they will discharge and stop working. It is not yet clear whether they will come back to life when the next lunar day starts. The landing came just days after Russia's Luna 25 spacecraft spun out of control and crashed into the Moon. The crash also put the spotlight on the difficult terrain of the South Pole region, where the surface is very uneven and full of craters and boulders. India is not the only country with an eye on the Moon. There's a growing global interest in it, with many other missions headed to the lunar surface in the near future, and scientists say there is still much to understand about the Moon that's often described as a gateway to deep space.